I'm Nuri Sinha, and my team is T-Titans. This semester, our team worked on a project for the 3rd Ranger Battalion in which we increased the range of their unmanned ground vehicle. The unmanned ground vehicle, or UGV, is a technology used by Ranger regiments to survey the battlefield without putting Rangers at risk. An operator communicates with the UGV via a controller, which sends control signals to the UGV and receives video and audio signals back from the UGV. When given to us at the beginning of the semester, the vehicle could travel up to 30 meters before losing signal. Our goal was to expand the UGV range to 150 meters.
Our project was required to fit within multiple technical constraints derived from the sponsor requirements. For example, our range extending system had to fit fully on the underside of the UGV and not interfere with its rolling arm. It also needed to be able to climb small stairs. As a result, any new system had to maintain high ground clearance. It was also important that if we took an approach that used the deployment of separate repeaters, that the operator could manually choose when to deploy the repeaters. In other words, the controller would need to interact with our deployment system and not be automated. Finally, we could not change the machine code inside the UGV, so as a result, we used our own microcontrollers and code specifically for an Arduino that we affixed on the underside of the UGV.
Our team went through 2 phase iterations. We started by selecting an overall approach to the problem. The initial ideas we investigated included retrofitting the UGV with a stronger antenna, wiring the UGV back to the controller, and dropping multiple range-extending pucks. A thorough analysis with an evaluation matrix based on projected constraints led to us selecting the multiple range-extending puck solution. We then selected the best option for deploying the pucks. The team put together a morph chart of necessary components for the solution, including storage, deployment, and signal transmission. From there, we identified 5 possible solutions. We selected a solution where the pucks hang free from the bottom of the UGV and are deployed by individual actuators. This solution saved space and kept the pucks deployment autonomous, allowing for better backup in case of drop failure.
We took a piecewise approach to the project, with the MEs working on designing ideal pucks and deployment mechanisms, and the ECEs working on assembling, transmitting, and receiving components and programming the controller to allow the operator to deploy the pucks. We were able to confirm early in the process that the transmitters and receivers functioned perfectly together, so from there it was all about assembling and testing. On our first iteration of pucks, we found that the puck and antenna size caused the pucks to be caught and dragged along by the UGV. We had to quickly pivot, find smaller antennas, and give the pucks a slanted shape so they would fall correctly. We also found that the video receivers needed to be manually turned on before use. As a result, we introduced Raspberry Pi microcontrollers to the pucks that would attach to the video receivers and allow them to function autonomously. Given that there were also components protruding from the sides of the UGV, the team found that each puck would need to hit different heights to maintain ground clearance. Slots were inserted on the sides of the pucks to encourage rotation throughout the fall to the ground, as well as minimize the chances of hanging pucks to become misaligned. As we were allowed to take advantage of the buttons and joysticks on the UGV controller, we had to decide which controls we wanted to use to drop the range extending pucks. We considered the buttons and controls available and eliminated any controls that might interfere with the existing UGV operations. Finally, we elected to have an operator stop the UGV and turn his camera joystick to the left and steering joysticks to the right. In other words, hold the joysticks out for 2 seconds. This is an action that the operator would not likely perform in the field, and it did not interfere with any buttons that already have uses. Further, a 2-second holding period ensures that the operator is intentionally deploying the pucks.
In the end, our team assembled 4 range-extending pucks that could fit directly under the UGV. The pucks are attached on one side with a solenoid pin and on the other with a small pin that provides basic support. When the operator moves the controller joysticks to an outward position, the solenoid pins move in and the UGV drops a range-extending puck. The operator can deploy the pucks when the signal weakens, and together the 4 pucks may reach the goal transmission distance.
A greater range for the UGV means that Rangers will be able to scope out an even greater area of battlefield while limiting danger to themselves. We hope a future team continues our work and provides for more operator feedback and even a mechanism to retrieve the range extending pucks at the end of the mission. Thank you!